All right, good morning everyone. I'm going to be doing another Leetcode question today. Let's do a easy and we'll pick one at random. And over here in the right you can see that I have a timer. So let's start the timer and see what we get. I'm going to be doing this mock interview style. If you've been watching this channel for any time, you've probably heard this before, but we're using a GDoc just because you sometimes don't get access to an IDE in an interview. It doesn't mean that IDEs are bad. It just means that you sometimes have a whiteboard only. So it's good to get some practice with a notepad, GDoc, whatever it is. So that way you're not kind of like tripped up by simple things like syntax highlighting or autocomplete kind of not being there for you. So let's have a look. We're doing Fibonacci number. Wait, I've done this one before. Let's try again. And try again. All right, there we go. 414, third maximum number. I'll just restart the timer. So what do we got? We've got third maximum number, and given an integer array of numbers, we're wanting to return the third distinct max number in this array. If it does not exist, return the max number instead. So an example is nums 321, output 1. First distinct max is 3, the second is 2, third is 1, and the output is 1 because it's the third largest number, max in this case, distinct max. So question I have now is what happens if we got three numbers that are repeated. We can see in example 3 they have 2's repeated, so the third distinct max will be 1 again because there's 3, 2, and then 1, even though there's multiple 2's. Okay. So there's some things I'm thinking about. First of all, you may or may not have heard of the concept of a max heap, and that's just a data structure for storing information in kind of a tree where you're percolating the maximum value to the top of the tree. And there's some nice like big O advantages of this. It also allows you to get the max n values really quickly. So that's kind of first thing that's jumping to mind right now. I'm not entirely sure how you implement that in Python. I think it's heapq is an existing standard library, and it's like push, pop, and so on like that. So you could do like heapq push or extend the array, and then you could do heapq dot pop 3 times, and you'd get the first 3 maximum values. And you can do that for a list, and I think that would be that may have some advantages. I'm just kind of spitballing at the moment out loud, especially with the interviewer telling them what I'm thinking. Some other things I'm thinking about is what happens if you don't have enough values in the array? Say you only have 2 integers, then you're returning the max in that case. Or if there was just 1, then you return that 1 value by itself. If it was an empty array, maybe you return none. Here it looks like the constraints they give us is promising at least 1 number, and a maximum size of this array is going to fit comfortably in memory with just 10,000 entries. The integers are all going to fit inside integer space, so yeah, between 2 to 31, minus 2 to 31, so that's just an int. So we do not have to worry about any sort of overflow issues here because we're not summing values yet, but that is actually something we'd have to think about in this case if that was relevant. We only care about distinct values, so one approach might be to take the set of all the arrays and then sort them and take the third from the largest value in there. That's another approach. There's maybe some pros and cons to that also. Approach 2 is set of array unique values. Sort unique values, take third largest index. That's one approach. Building a set would be O of n for n elements time, and O of n space, assuming n unique elements also in the worst case. To sort this would be, let's say you used a quick sort. I think the default for sorted for Python is quick sort. So that would give you O of n log n for time, and space is O of 1 in this case because it's in place usually. So this approach is okay. I'm not a huge fan of it because it's doing quite a bit of extra work. So the final is O of n log n time and O of n space. I'm so kind of starting to go back to the first one. So let's just keep thinking about it a little bit more, because we're always trying to get just the third maximum value. We don't have to sort the array. We can just iterate through the array and keep track of the three largest values iteratively. So this one will be the simplest and probably the one we end up going with. So the idea is iterate through the array. We hold three values, track three largest, update largest as we move through those three, through the array, if they're unique greater than existing, and at the end return the final. So this one is the easiest, I think, and also the fastest, because it's O of n time, O of one space, and because all we're doing is storing those three largest values. I think the only things to keep in mind is making sure we're dealing with distinct values, and also the special case of if there's not enough distinct values, that we return the largest one we've seen instead. So in this case, the third doesn't exist. We don't want the second largest. We want the first largest, the biggest largest one. So, okay. I think this will be fine. Let's put this all together. I'm just trying to think about, just getting rid of all extra spacing. The approach one, the first one I was thinking about, I don't remember exactly how heap queues push pop max heap approach. There's some advantage to this in say we had an extension of this problem where you have a incoming stream of integers and you're trying to return the third largest max at any one time. Actually, I think approach 3 is still the best for that case, iterative, because we have a limited number. But approach 2, technically you don't even need to have the set of unique values. You could just let's say we have approach 2.1. The reason I'm going through this, even though I know we're not going to use this one, is sort and then iterate to third largest. This would just be O(n) log n and O1 space. It's kind of similar to approach 2, but we don't have to create a unique set of our unique values. This is I'm trying to think of a situation where this would be better. I can't think of one right now, but it's possible that the interviewer can kind of like modify the question here to make this approach one of the better ones. So just keep that in mind, that this is an option, sort and then iterate. We're not going to go with any of these. Oh. And the max heap one I think is interesting and might be useful if you don't know how far into the max heap you want to go. I'm trying to remember here, sorting, this isn't a full sort. So in some situations might be faster than approach 2. Okay, I don't want to get too sidetracked. We're about 7-8 minutes in. Let's get to approach 3 for the iterative approach, and let's just start coding it up right now. I'm trying to think of any other edge cases that's there. Oh, there's the follow-up. Can you find an O of n solution? Well, I think we'll be able to do that with this one. I might be wrong. We'll find out. Okay, so let's just start filling it up. This is called third max, as it shows right over here. And we're going to take in a list of ints, and we want to output an int for the largest max that we get. And we're guaranteed that there's at least one number. So let's just say we have max vals are maxes is equal to an array of none, 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 and they have to always be unique. So the way we can do this is if the length of nums is less than 3, so if it's equal to 1, just return the value. else if length of nums is 2, then we have the special case of just wanting to get the max value, max of the max of the two numbers. Now we know there's at least 3. And technically we don't need all of these. We might not have to, but it's nice to have them kind of set up ahead of time, and we can remove it later if we need to. So what I'd like to do is iterate through the list for num and nums. And then we check if, and what I'd like this to be is biggest, second, third, in that order for these maxes. And we'll check if maxes of 0 is none, or maxes of 0 is less than num, then num maxes of 0 equals that. Similarly, we do that for the other two. But we want to make sure that the second one is different from the first one. So if maxes, all right, so let's work out the logic here, because otherwise we're going to kind of get into if statement hell, and I don't want to get too stuck in the weeds there. What I'd like to do is, let's word it out basically. If the number is set biggest number if num greater than that, set second biggest if num greater than that, but not bigger than first, set third biggest if num greater than that, but not bigger than either two others. And then I think that's it. I'm trying to think about whether you need to percolate numbers up. So let's say the number is bigger than the third biggest, but we also want to make sure it's not bigger or equal to than the bigger either other is not greater than or equal to the first. Yeah, okay, so this will always percolate upwards. I'm just trying to like work out the idea here. So let's just say 2, 2, 3, 3, 1. Let's actually run through an example here. So 2, 2, 3, 1, and we have our maxes is equal to none, none, none. So on the first number 2, we are wanting to set maxes as 2, none, none, like that. And then on the second one, we get another 2. It's equal to the first one, so nothing changes. Then on the third one, we have replaced the first one with the 2 with a 3. And actually what we want to do now is percolate that 2 down to the none below it. And that's a thing I was missing actually earlier. Push down. Push down. Previous biggest. And the same applies to here. Okay. And then finally we get the 1, and here it's not bigger than 3, it's not bigger than 2, but there's still a none, so it just replaces that, and that gets us our correct ordering, and we can return our final value. And also one of the things we can do is if this 1 had never existed, we just check if the third is none. If the third is if maxes of the third value is equal to none, return maxes of 0 in that case. Okay. And technically we could initialize the maxes with the first value in the array, because we're always going to at least start with that. Tempted to do that, but that is technically not necessary, so we won't do that just yet. All right, so how do we push the values down? Let's do a check. So the idea is, all right, if num is greater than the biggest num, or not none, let's do it in that order so it's easier to see. then we want to replace that and also push down the original value. So maxes of and the way we could do that, this is not the way we're going to do it just yet, because we have to replace maxes of 1 and 2 as well. So pushing that down is we could use a queue here instead of trying to manually iterate these things. That might be worthwhile. This is actually where an argument for the max heap does make sense, because we just need to push and pop within it. I'm trying to avoid doing that. I'm not sure why. Just because I don't remember exactly how to implement the max heap here. I think it's as simple as push and pop. So let's just say we have access to heap queue. I think we do. And let me do a check actually right here. Heap queue. Push. So let's say max is equal. Actually, I'm gonna, let me not pause, but I'll pause the video feed for a second, but I'm still running the timer. I'm just gonna quickly look up. Well, no, that wouldn't really be fair. So let's not do that. We won't use it. And I'll come back to that after we finish the interview. All right, so let's see. What I'd like to do is push down to the second and make sure that second one pushes down to the first. Third, if needed. Actually, it'll always be needed because we're always going to have unique values in there. There's never a case where we can't push down the first into the second and not push the second to third. So actually that is a little bit easier than I thought. So we just say maxes of 2 equals maxes of 1, maxes of 1 equals maxes of 0, maxes of 0 equals number. So we just pushed everything down. Push first down to second and push second down to third. And we have to do it in this reverse order so we don't replace the wrong values first. So we did that for this one. And that's if maxes of 0 is not none or num1. So replace largest. Then we want to do the second largest, else if maxes of 1 is none or num is greater than maxes of 1. And we kind of do the same thing, but this time we just need to do the last two. So maxes of 3 gets pushed down. Maxes of the second largest gets pushed down to the third largest. The first one gets set to this number. And that's all that needs to be done there. So let's just put that here. Push second to third, replace second, and this is replace first. Yeah. And then finally, set the third biggest if that is, but not either of them. Else if maxes of 2 is none or num is greater than maxes of 2. Then this one is just maxes of 2 is equal to num. And that should be it for that. And we just kind of go through all this and then we do a check. If maxes of 2 is not none, return it. Otherwise, we return maxes of 0, the first value. Okay, and I think that's just our full iterative approach right here. I think we could have done this with a heap queue a little bit faster, so we might be able to go back to that later. But it is good to kind of have this laid out, and you can kind of see talking it out loud. I think this should make sense to me. I haven't decided if I like the fact that I use an array rather than a individual values. One of the reasons, or individual names like first, second, third, I think this was a little harder to parse and read. However, let's say we were to try to get the fourth or nth largest, kth largest value in the array. You can make a loop to do this kind of push down process, and this would translate to that quite a bit easier. So let's keep that in mind for next time. For now, let's see how this does. I think this should be okay. So let's see what we have. And I had to remove all the tabs and turn them into spaces in this case. If anyone has any suggestions for how to avoid doing that, let me know. Okay. So the for loop goes up to here, there. Okay, that should be about all of them. And it has to be greater than. That's how we're getting distinct values. If we use a greater than or equal to, then we could have multiple values that are repeated. So let's just think about this for a second. Is it possible that we are replacing a number with the same number? It doesn't happen in the largest. It doesn't happen in the second largest or the third unless they're empty. Okay, so that is a problem. That's one thing I haven't added here. We don't want to set none if the maxes of 0 is equal to that number. So one way we could do that, and I'll just do it here just for clarity. So what I'd like to do is make sure this is true, and also num is not equal to the previous one. And we're going to have to do this here as well, but not just for the first, but also the second. And this gets a little complicated, so I'm not a huge fan of it just yet. Let's put this in parentheses just so we can put the and in its own line. There. So here what I'm trying to check is that the number is not one of the previous maxes, either the first one for the second or the first or second for the third. And then it's also replacing an existing one that's either greater than or doesn't exist yet. So as long as it has those two, we should be okay. Okay, I'm just leaving this here for making it about the same. So let's see. Then if max is not none, returns the largest. If it exists, or first largest, otherwise. And we're kind of guaranteed that there's at least one number, otherwise it'll do these things. But also here in the constraints, we're getting at least one. If we wanted to do a check if the length of nums was 0, then we'd return none or empty. That's an option too. So let's check and see how this does first of all. We're at about 22, 23 minutes and we have a typo. And the typo is right here. Else if. Is Python, I think actually Python might be elif, so apologies for that. I think that's it. Let's see. Okay, seems to pass the test cases. That's good to see. Let's try submitting it and have a look. All right, cool. And it was accepted and it ran in average time. I think the amount of time it takes to run this isn't going to be that important for an easy question. It's good to be within the right ballpark, but there's going to be some tricks and tips. Not tips, tricks and little shortcuts that take advantage of the C backend in Python for running on Leetcode that doesn't have to do with the algorithmic complexity. Like there are some cases where running like a more inefficient algorithm is faster on Leetcode just because of what's on the backend for the type of questions it runs. That does not mean it's the better solution a lot of the time, especially in an interview and honestly in real work. So try not to pay too much attention to the amount of speed or memory, unless it's really far off base. Once you get into the more medium or hard problems, that'll start to be more accurate because it'll be a much more computationally complex problem. Okay, pretty happy about this. I think the parts I'm not happy about is this complex kind of if-else statement. I think we could probably clean this up somehow. So that maybe is the next place I want to look at. What could we do here? And let's see. I think the big one is how do we use max heap. So we're done with the problem. Let me just stop the timer here and let's see. All right, so I just did a quick look at heap queue, and it's not exactly like this, but there's something along the lines of a heap queue dot n largest that returns the largest n values. Thinking about it a bit more, a max heap is just a binary tree. At least in Python's implementation, it doesn't have to be binary, but it is here. So generating this tree is it's a binary tree, so it's n log n anyway to build tree. And honestly, even if you're not fully building the tree, you're just trying to get the largest n, I think it's still going to be an n log n process because you have to check every single value and put it somewhere within the heap to semi-sort it to get the largest values. Pull, pop, top 3 values. So this is going to be similar to approach 2 in terms of the final time complexity, space complexity. So honestly, in this case, I'm leaning towards sorted rather than using a heap queue. If you have a lot of experience with this one, feel free to use it. I think there's an argument to be made for using it in this process right here. So we could do something like a, we'll call maxes an empty array, and then we could do a heap queue dot, I think it's heap push the value. And you only want to insert unique values, so it's almost like a set. Actually, one argument for this is a sort. You kind of want a sorted set. What I'm thinking is you want a sorted set of max values. You push in new values and reduce the size of the set to keep it at 3. So one could do it in this way, and I wonder if Python has a sorted set approach. There's like, you could do some little shortcuts like the set of maxes and maxes dot append the new number, and then you could just create a set of that and then sort that set as a list, and then you just keep the largest last 3, I think -3, something along those lines. These are all kind of like one-liner shortcut tricks you could use, but they don't really do anything except sometimes use the backend C, which might be a little bit faster, but there's a lot of extra work being done here in generating new sets, sorting the sets, creating a new list out of this. It's this would quickly become pretty inefficient, I think, at large scale. So it's not that you shouldn't use this, it's just that generally in an interview, it doesn't writing this doesn't show much more than like being a little bit clever. It doesn't explain whether you understand the concepts of it or not. I'm trying to think of anything else. I would like to push this a little nicer. So let's think about that for a second. Could we have maxes as just this array, and then we maxes dot push, or insert into position 0 the value, something like that, as long as it's greater than the previous one, and then we just remove the last array. Something along these lines, and that way we don't have to do this process of replacing each value individually. Instead, we have this queue essentially, or linked list. And if we were doing this with more than 3 values, maybe there was like a k distance, then this actually would make a pretty good sense. There might be an argument for that. I'd actually be interested to see if this becomes a medium question later on, where you're passed in this type of get the nth max value. If I do get that question, I'll try to link it here below at some point. Either way, hope this was interesting for everyone, and see you guys next time.